opinions expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and freedomslips.com, its staff, or affiliates. You're listening to Revolution Radio, freedomslips.com, 100% listener-supported radio, and now we return you to your host.
Ladies and gentlemen, welcome back to another episode of Cosmic Catastrophe on Revolution.radio. I am your host, Diamond, from the Oppenheimer Ranch Project, and this is my lovely co-host and partner, Leah Shaper, joining us.
Hello.
Welcome to the show. As usual, we're going to be talking about something fantastic, but in this case, we are going to go back over one of the most important cosmic catastrophe events in recent memory, and we're going to be talking about as if it is in our memory. And that is none other than the Younger Dryas event, which is a double whammy, a two-part event. 12,008 or 900 years ago, it got very cold, and it stayed cold for about 1,500 years, and then 11,500 years ago, it warmed up, almost like a button was pushed. Now, there are many people working on what happened during this event, and it is a general consensus that a cometary body fragmented and affected our Earth and maybe our sun, specifically smashing into the Laurentide ice sheet, and then the subsequent millions of ice bolides going into space, forming the Carolina Bays. That would be the trigger for the 12.8 event. And it may all be coming from the Taurid meteor stream. But the mystery is what ended the Younger Dryas event? How did we just go from back into the Ice Age all the way to the interstadial almost instantly?
Yeah.
So we're going to be talking about that. And the title of the show is The Younger Dryas. The Younger Dryas. What would it be called? It would be the Younger Dryas impact hypothesis in myth.
Sure.
How's that sound?
Sure. You know, I was thinking yesterday, partially because of an argument that I was having with somebody on Twitter, who basically believed, this person believed that, you know, all of climate changes are attributable to the Milankovitch cycles. And you and I don't really agree with that, but this event, the Younger Dryas and the Bowling Alley Rod, is a great example of why that can't be the case. I mean, we're seeing these extremely abrupt shifts in climate from the Bowling Alley Rod and the Younger Dryas that doesn't fit into any system. And it's such a perfect example of what we don't understand and what we don't know about affecting our universe, because it's clearly very extreme, this event, because it's so sudden, the shift.
And whatever the Milankovitch orbital perturbations are, they have them listed as a change in our eccentricity at about 100,000 years. The precession of the equinox is the standard catastrophe cycle, or the great year, 26,000. There's also an eccentricity cycle where the shape changes of our orbit, and that's about 41,000. What's interesting is I kind of agree with you in the sense that Milankovitch can't be the driving force in the climatic changes on Earth when you simply look at them, when you look at the raw data and you look at the Milankovitch cycles. Mm-hmm. But there is a correlation to solar insolation and these temperature changes. We'll get to that at the end. But the point is, it doesn't seem like a simple, slow perturbation all of a sudden when you're here. It's like trigger. That makes no sense.
That's exactly what I mean. I'm not saying that Milankovitch cycles don't play a role, but they certainly cannot explain an abrupt event like this. And so this is the most recent, very extreme event that has happened on Earth. And so we keep coming back to this example again and again in terms of trying to figure out like what happens here. It's just a perfect example, which is why we keep revisiting it. And we have a lot of data about it. So it's interesting.
Yeah, and I think the Younger Dryas event, the anomaly in the normal 104,000 year warming, has to do with a cometary complex. And a lot of people have speculated it would be the Torrids.
Right.
Now, the Torrids are an annual meteor shower that are associated with the comet Encke. And there's actually two separate showers with a southern and a northern component. The southern Taurids originated from comet Encke, according to astronomers, while the northern Taurids originated from the asteroid 2004 TG10. But some people think that the asteroid 2004 TG10 is the parent body for both of these, meaning that comet Encke is a tiny piece from an original parent body of 2004 TG10.
I was just reading that as well recently.
So
I mean, it kind of makes sense, right? Like this might have been a massive comet at one time, and what we're just seeing now is the products of disintegration. And some of those pieces are quite big and are comets unto themselves, right? They're not dormant. They're still electrically charged. They're all traveling together. Yeah.
Well, there's an asteroid out there, so it's non-electrified, that may be the parent body. And then there's a comet that's electrified that may have gotten electrified during the breakup and the event.
Right. And the asteroid may just be basically electrically dormant.
Yes, exactly. Yeah. Or it may have shorted out during the breakup of all this.
Right, right.
And so these debris fields, these streams are massive and contain an unimaginable amount of objects. It's only recently people have even delved into the science and tried to image them or to suggest. So here's the interesting thing you and I have talked about. They have determined some cycles where we enter thicker and thinner portions of the stream. Have you read about that?
Yes.
Okay. Well, let's finish the whole concept of what science says about the Torrid complex. And then we'll get into the streams, and I have some visuals. Comet Encke and the Taurid complex are believed to be the remnants of a disrupted 40-kilometer class comet from 10,000 years ago. Now, other people suggest that it may be a bigger comet or even the same size, but push the date back even further, doubling the age or more. And I'm sure you've seen that. Mm-hmm. It's been 35 years since Victor Klube and William Napier tossed out the radical idea that periodic comet 2P Encke, unusual for its short 3.3-year orbit, is more than just the source of the annual Torrid meteor shower. It's actually the fragment of a much larger comet, and these guys think that original comet was 100 kilometers across.
That's a monster.
I mean, how big is that? That's like the size of Connecticut. Yeah. That's a big boy. And according to Victor Klube and William Napier, the comet broke apart 20,000 years ago. And this is pretty nice because if it started breaking apart then, it might have been on a doomsday course once it broke up into the sun and into the earth, starting around 13,000 years ago. It may be the first Dryas, the second, and the younger Dryas. We're going to get to the graphs, but the younger Dryas isn't really that unique. There were 3 drop-downs in temperature, all very similar to the bottom. And that very well have been periodic and episodic bombardment by these fragments here. And in the visual that no one can see, but you can see that there's a Torrid resonance swarm, and then there is another debris field. So there's 2 debris fields associated with what was once potentially a 100-kilometer wide comet. Pretty awesome.
Yeah.
So the most widely accepted theory now is that 20,000 years ago, the much larger object broke up, creating Comet Encke and several asteroid and meteor showers. And then scientists named the group of the resultant objects after the most prominent number of the group, Comet Encke. Hence, they named it the Encke complex. Pretty interesting?
Yes.
And so these Torrid meteors come from multiple sources. This may be due to several catastrophes over a period of 20,000 years, and it might even be older. It might explain all of the flash frozen mammoths because they date back to about 47,000. So if that was the beginning of some of the first impactors in the Arctic, it could explain all of the frozen mammoths all the way up to the end of the Younger Dryas event.
Yeah. Yeah, I am definitely starting to get this impression, generally speaking, of, impactors occurring from this stream more often than we realize.
Yeah, and they made a bold prediction. They've only really honed into the multiple streams. In 2019, they did a study, and the study investigated the potential risk of the Taurid meteor swarm to Earth, considering that at that time, which is now about 5 years ago, they thought that a large bolide, maybe a kilometer wide or so, similar to the Tunguska event, hits Earth once every 1,000 years.
Yeah. Yeah.
But based on our discussions in the last several years, objects 10 times that size probably hit at a frequency of a few thousand, meaning the smaller objects can happen anytime and all the time. And for some reason, not a lot have hit during the modern world. It may be due to the fact that we have a strong sun and it keeps the objects away.
That's possible.
Our magnetosphere is deflecting them.
Yeah. Yeah. Well, and I mean, we're sort of talking about this, and you sort of alluded to this earlier. And last year in an episode, we talked about the concept of coherent catastrophism, right? Where there's sort of a like, so if the Torrid meteor stream is about 6,000 years, the material is sort of in sections, right? So we're going to go through periods where we don't encounter a lot of this, and then periods where we do. And then also there's this quote from that, I think it's from that same Klube, Asher, and Steele paper. It's called "The Structure and Evolution of the Torrid Complex" from 1991. And they
Take a look at this visual.
Yeah. Yeah.
So if you could think of the stream as being tens of thousands of kilometers wide and maybe 1 million miles long,
right,
then you can understand that each time we interact with it, we are in a completely different place.
Yes.
We're not going in the same spot every time.
Right.
Go ahead.
Right.
So what were they saying?
And so the quote from this paper is, since the majority of the ejecta from a comet, especially the larger masses, would remain in orbits close to that of the parent, we find from our integrations that there are epochs of large influx to the Earth, which last for several hundred years and are spaced apart by several thousand years. So, despite the fact that the Torrid meteor complex, the orbit is or Encke's orbit is 3.3 years, and I guess the meteor stream as well, that we're still only going to encounter a lot of this every few thousand years.
And that would explain the 3 drop downs in temperature as we went into the Younger Dryas event that lasted from about 14,000 years ago to 12.8, and a periodicity of each several thousand years dropping drastically. So we could be getting bombarded for hundreds of years each time, every few thousand years in the beginning of this catastrophe, ending in the final hurrah, potentially. We could have a weak magnetic field, which we do at the bottom of the Younger Dryas, drawing in all of the objects at the end event. Mm-hmm. And now we just have meteor showers. Or do we? Because 6,000 years ago, we have some large objects hitting Earth.
Yeah.
Yeah.
Well, I was going to say, too, you have to also consider that over time, as time marches forward in thousands of years, I think it's reasonable to assume that the debris field itself is going to get less concentrated.
Yeah.
So for 2 reasons. One, because there have been events in the past which have broken up comets and surely parts of the debris field. And then also just because that group of objects is likely to become less coherent, less stuck together, so to speak.
Yeah, and we know that planets, magnetospheres, or their gravitational effect have the ability to rip apart these objects if they're close enough. Mm-hmm. We witnessed in the 90s Shoemaker-Levy 9 break apart into dozens of pieces as it entered Jupiter's atmosphere.
Yeah.
And so they didn't expect that.
Yeah.
They never expect what happens.
No.
And according to the
because
the electric universe model at the time, they predicted that there would be plasma discharges above the surface before the impacts, which is exactly what happened.
Exactly what I was about to say, right? You have this electrically charged object coming at a big planet there's likely to be an electrical interaction, and surely there was a plasma discharge that breaks up the comet.
Yeah, and that was all predicted by Wal Thornhill, rest in peace, Wal.
Yeah.
Who predicted many things and got many things right.
Yes.
So it's only back in 2019 where they started to look into these streams of comets associated with Encke and the Encke complex. And a study from Western Washington posited proof to the possibility that an oncoming swarm of meteors likened to the Loch Ness Monster or Bigfoot by some extraterrestrial experts may indeed pose an existential threat for Earth and its inhabitants. Now, this is interesting, but because according to the Western Meteor Physics Group data set and their analysis, they said that in 2019, the Earth was going to approach within 30 million kilometers of the center of the Torrid complex, and they were worried. They thought that was the closest that had been ever, and they thought that that could have been a triggering event. But the good news is nothing happened in 2019, no impactors.
Yeah.
Now, here's where it gets interesting, and it sent chills up my spine. What else do you think they concluded? They concluded that the next time we will approach the center of the Torrid stream is going to happen again in the early 2030s. So I bet you there's people that are trying to crunch the numbers on that one.
Yeah, I mean, I don't think you and I do not know, let's say, what the periodicity is of running into this stream.
No one does.
Right? No, we don't. But just from the history that we do understand, it does sort of seem like we're due.
All right. So according to this study, which is now 4 years old, so nothing happened when they posited we were getting close to the center. Mm-hmm. Close to the center, according to them, was 30 million kilometers. I wonder how close to the center we're going to get in the early 2030s.
Yeah. Well, and by the way,
it makes you think of Agenda 2035, right?
Yeah.
Why that date?
Right. Well, and you also have to think too that if we're looking at, let's say running into this every few thousand years, whatever that means exactly, 2019, the margin of error between 2019 and 2035 isn't really that much. Like, I don't think their 2019 prediction was necessarily so off. It's probably within the margin of error of their calculations.
Yeah. So the next time we enter the center of the Torrid swarm will happen again, according to the Western Meteor Physics Group data analysis, in the early 2030s, which means there's going to be another paper coming out because it's been quite some time. Mm-hmm. Now, I wonder if it is the resonant swarm or the other swarm. See, there's multiple swarms.
Yeah.
And so here's
I
what's
want to
also
throw something in here. Well, go ahead. Say what you're going to say.
In 2017, before they did the 2019 study, and I think it probably sparked the 2019 study, is that they discovered a new branch. See, they think that there's only two branches of the Taurids, right? The resonant and the main field. But what they discovered in 2017 is a new branch of the Taurid meteor stream within an existing stream. So there are thicker streams within each of the streams.
Well, then what about the beta Taurids? Right? Because there's the northern, there's southern, and then the beta.
So that's probably that would be the new stream.
Right. And I think the beta Taurids appear at a different time of year than the northern and southern appear at like a relatively close time frame in the calendar year, and I think the beta Taurids appear in a different season. October
through December. We'll just go over that real quick. This is for the Torrid meteor stream in 2024. It would be completely active from October 20th to December 10th of this year.
Yeah.
And both of the main showers will produce about 5 meteors per hour, 10 when they overlap, and some of them will be fireballs. So the predicted peak of the South Taurids this year is November 5th, just right around the election.
Mm-hmm.
That's at 7 o'clock UTC. The Northern Taurids are peaking on November 12th. So the peaks are very close together.
Yeah.
And it's not expected that we're going through the center of the stream either, which is good news because we don't need that right now.
Yeah. Yeah. I'm going to throw this out there too. So last year, about a year ago, we did this episode called Decoding Gobekli Tepe using archeoastronomy, which was largely based on two papers that look at the carvings in Gobekli Tepe and determine that there's a bunch of archeoastronomy here that would seem to correspond to what happened at the Younger Dryas. And I was kind of looking back on my notes about this because it's related to these myths that we're going to talk about. And the authors identified two pillars that they think represent the northern and the southern Torrid meteor streams. And they, cycled back the clock on precession. And according to their interpretation of the asterisms on these pillars, that's what they identified. On one pillar, it shows the northern Torrid meteor stream. On another pillar, it shows the southern Torrid meteor stream, and it shows exactly where the meteor stream would have been coming from in the sky at 9530 BC. So it's very interesting because there's a lot of information to suggest that the people who built Gobekli Tepe were watching the Torrid meteor streams very closely, noting exactly where they came from at this time. So it's like, I mean, obviously that interpretation is subject to debate, but if it's true, the Torrid meteor streams have been really important to humanity for a long time.
Right. And so if this was initially the breakup of a 100-kilometer body, everyone would have seen it on Earth coming towards them. It would have been terrifying. They would have watched it break up around 20,000 years ago. And for a millennia, thousands of years, it would have returned on a regular basis, terrifying people in the night sky. It might have even been the result of some of the plasma discharge petroglyphs that we see that are dated 13,000 years old.
Yeah.
And so it would be ingrained into memory that this is the most important thing that humanity needs to look out for.
Right. And if you're going to spend time carving this extremely elaborate complex of which we've only uncovered like 5%, which does appear to be like you once put it, like an Encyclopedia Britannica of the astrology, of the astronomy of our galaxy and what happens. I mean, if you're going to spend all of this time doing that, it's obviously really important. Like, you're doing it for the posterity, for your children. You're trying to teach them what's going on in the universe. Perhaps you're doing this to teach future generations to, when the string of oral history has been lost, those stones and those carvings will still be there, provided that they can be interpreted accurately. They contain a wealth of information that would seem to be very important to us today, 12,900 years later.
Some of the most basic information that you can glean from looking at the circles at Gobekli Tepe are in the bas-reliefs of the animals. It's over 50% of the animals represented in those bas-relief carvings were never present in Anatolia. So it's clearly an encyclopedia of animals from around the world. And it's a place you could take someone that's never seen a jackal or a hyena or something like that and show them the carving and explain to them what it is.
Mm-hmm.
Yeah, so it's that alone shows that Gobekli Tepe is being used as some sort of school. That's the easiest way to put it.
Yeah, that's how I think about it. Yeah, like a school.
All right, so before we get into the myth and how it appears as if we have writings that show that not only did we witness the end of the last ice age, many different groups did, and they passed down these stories, and they exist today. And why a lot of people don't really dive in, I'm sure many have, but why it's not more important is beyond me. So let's tell the whole story before we get into the myth. The last ice age, and when they say the last ice age began 125,000 years ago, that's disingenuous because it's just the last glacial cycle. The ice age has been going on for 3 million years.
Yeah.
2.8 to be more exact. So the last ice age cycle which began 125,000 years ago, reached its maximum during the last glacial maximum, which is around 20,000 years ago. At this time, large parts of the northern hemisphere were covered in kilometer-thick ice caps, and sea level was 120 meters lower, almost 400 feet. Large tracts of continental shelves, which are now submerged under 300 feet of water, used to be seafront real estate, and perhaps supporting many thriving maritime ice age civilizations, including places like Beringia. And the size of Florida was almost 8 times larger than it is today. It's a lot of people down there. Well, what happens is around 19,000 years ago, the weather began to warm up, and the ice sheets started to melt and retreat, resulting in gradual sea level rise. The Barbados coral reef borings reveal that a massive pulse of fresh water called Meltwater Pulse 1A was released into the oceans from the melting ice caps between 14,690 and 13,730, which raised sea level 24 meters. And this took place during a sudden warm phase known as the Bowling-Alarod Interstadial, which extended from about 14 to 13,000 years ago. So I'm sorry if you're listening on radio, you can't see this.
Well, just come find us tonight on Magnetic Reversal News at 8 p.m. Mountain.
So right here, 14,700, there is a massive pulse of fresh water into the ocean. So I think some of the first pieces are hitting the Laurentide ice sheet, just not in a super catastrophic way.
Mm-hmm.
Minor impactors, and it's also the same time, this is the same time that the channeled scablands form.
Yeah.
Which is the largest outwash flooding known on Earth. Massive fresh, go ahead.
I was just going to say, when you said, talked about an impactor hitting the Laurentide ice sheet, I mean, there is definitely evidence at this time frame of some kind of cosmic effect, because there's a huge radiocarbon spike at 14.3.
Oh my. Which would explain the vertical nature of both of these lines.
Exactly.
Some cosmic catastrophe occurred and we warmed rapidly, and that backfired.
So, I mean, it could be like a Miyake event. It could be an impactor. There's options here, but something very significant happened.
Yes. So what we have going on from the period of 14.7 to the end of the event, which is 11.5, I think is multiple things. Yeah. I think it has to do with the sun, and I think it definitely has to do with the Encke complex. Mm-hmm. Whether one section is from the Encke complex being torn apart by the sun and bombarding it, and there's a solar outburst, which warms us up in the bowling, and then subsequent smashes on Earth cause too much fresh water to hit the ocean, shutting down the thermohaline cycles, rapidly cooling the Earth. And at the same time, those cycles would be shutting down. If something's hitting the ice, the amount of steam in the air would block out the sun. So you block out the sun, you stop ocean currents, and it's almost like a day after tomorrow.
Yeah, yeah. And no matter what the initial cause is, there's going to be a domino effect, right? You don't have a major effect like this and not have it affect the other variables on planet Earth.
Yeah, and so a domino effect here, starting with the cooling events during these different Dryases, lead us to the younger Dryas, and each of these is separated just by a few thousand years, just like you said, until the big boom. 12.8 is the mass extinction right there.
Yeah.
And that is when the big stuff hits the sheet. We get the Carolina Bays, and the world goes dark. Tsunamis wash across the oceans, and almost everyone dies that's a human. 65% of megafauna in North America and other continents are erased in a second, and the majority of the Clovis population is erased, and their culture, and they come back as a different named group.
Yeah. With different technology, of course, because
it's slightly
different. Have changed.
It's not that different.
Right. It's somewhat different.
Yes, it's somewhat different.
Yeah.
And so that would be a few generations passing, and then the new culture happens.
Mm-hmm.
So you might be in caves for 3 generations just to live. It's still dark for 100 years, and you're teaching each generation how to make these arrow points. It's going to shift.
Yeah.
Because your source material is going to shift. You might not be able to go as far. All the big animals were easy to get are dead.
Mm-hmm.
It's a weird time. Okay, so we just blew your mind on way too much information, too quick. Now, for a long time, scientists were unsure as to what has caused this abrupt reversal to ice age conditions. But in 2007, a team of international scientists led by Firestone found compelling evidence that the Earth was bombarded by multiple fragments of a giant disintegrating comet nearly 12,900 years ago. And we just went over all that. So the period of bombardment and destruction probably only lasted, like you said, maybe a few years or more. But the cooling lasted for over 1,000 years.
Yeah.
And this is confirmed on almost all ice core data.
Yeah. Yeah.
So in an interview with the Danish paper Politiken, Stephenson said that the transition from ice age to our current warm interglacial period was so sudden after the Younger Dryas event that it was as if a button had been pressed. In the span of a single year, temperatures increased 10 to 15 C in many parts of the world. That is insane. In spite of the fact that the end of the last ice age has now been narrowed down to September 3rd, 4 p.m., 9703 BC. Isn't that crazy?
He's joking about the date, the September 3rd part, but
yeah, but they have narrowed it down to a single year, 9703 BCE.
Yeah, yeah,
that is insane.
And you know what else is interesting?
Bad.
No
bumper?
Well, no, there's too much detail for me to get into this right now. I'll get into it later. Never mind.
All right, so now we're going to talk about what happened in here and relate it to myth. And we're going to jump right into the story of Indra kills Vritra, the enveloper. And this goes all the way back to the Rig Veda. The Rig Vedic legend of Indra killing the dragon Vritra has been repeated in many hymns of the Rig Veda. And it appears to be describing an agent for the end of the Ice Age. The echoes of the same story can be found in the Mesopotamian legend of Marduk slaying the water dragon Tiamat, as well as the Cherokee folklore of the god of thunder killing the monstrous water serpent Uktena, and then the Greek legend of Zeus killing the serpent-headed monster called Typhon. So, what's going on here?
Well, what's really remarkable about this is that Indra is like the king of the gods and he wields thunder, right? And he kills Vritra, which is like a sea serpent, or not a sea serpent, like a dragon, the enveloper, as you said, who's holding back the waters of the 7 rivers. These are the rivers that are the tributaries of the Indus. And then you've got Marduk, right? And this I find really fascinating. So apparently Marduk would have been more pronounced like Martuk.
Yeah, Marduk.
Which sounds an awful lot like Maratvat, which is another name for Indra, because it means the leader of the Maruts, which were like his little side deities that like accompanied him. They're little sky gods that go with him everywhere. So Marduk is also the god of thunder and war. But Indra and Marduk both ride chariots. One's drawn by 2 horses, one by 4 horses, but they're both these thunder gods. And then Marduk kills Tiamat, who's a sea serpent, who is like her eyes become the Tigris and the Euphrates River. And so when that happens, the water is being released. And then it's kind of the same thing with the Cherokee god of thunder, kills Uktena, who's a water serpent, and Zeus is also a thunder god, right? Who kills Typhon, this serpent-headed monster. And it's like in every case,
And
the
don't
hero-
forget, Zeus wields the thunderbolt of the gods.
Well, so does Indra and Marduk. They have these like double-headed tridents, and they're all talking about, you know, these tridents and the lightning that they use to kill the serpent that's holding back the water. So it really looks like, in essence, the hero of the story is actually the comet, right? Where in an ice age, all of the water is being held back. And then this comet comes along, you get these plasma discharges and all of this thunder and all of this chaos, and that's all being caused by the thunder gods. And then all of the water is released because it gets warm. And Graham Hancock goes even further with this because he looks at, you know, the pulses, the Bowling-Allarod pulse, and then, you know, it's not like if you had the Bowling-Allarod warming, you would have some amount of melting, right? That's meltwater pulse A. And that, but then we go back into the ice age and everything freezes up again. So like Graham Hancock points out that, like in the Himalayas, you would have had these glaciers that were retreating, but then they extend again and they block all of the water up in the Himalayas into, like, you know, lakes or whatever. And then when it warms again, suddenly all of that water gets released.
Right. And this graph is temperature. This sea level rise graph shows sea level stops rising. It doesn't drop again. So it rises 27 meters, then stops for this whole time, which is like 3,000 years, is a lull. And then it rises very rapidly at the end.
Yeah. Yeah.
So it's kind of interesting.
Yeah. Yeah. I mean, and the other part of this that's
so what I'm getting out of that is that these myths are literally a story of this 4,000 year period.
Yeah.
Yeah. Not just the end of the ice age.
No.
Okay,
but also the story is getting passed down from generation to generation and culture to culture, right? So like that's also really significant. And then the other thing that is really striking,
and the effects would have been the same worldwide, right? In India, they would have had a big melting, or in Russia and in Europe, and it doesn't matter where you're at, you're going to experience this flood.
Yes. And it's going to be it's going to be like the most significant thing that's happened on Earth in, you know, I don't know, 20 generations. Like, it's going to be extremely important to tell this story. But the other thing that I find extremely striking about these stories is, like I said earlier, it's essentially, it's the comet. It's like the thunder god. It's the god with the thunder and lightning, which, you know, would be probably what you would be seeing on Earth is like, maybe you see an object in the sky, but then there's like a plasma discharge, right? So the object in the sky is the god, and the plasma discharge is the lightning. So in effect, it's the comet that is the hero.
Well, and you're going to have sonic booms if they're entering atmosphere. It's going to be terrifying.
Yeah. Well,
and it comes back periodically, so the god myth will stay. Oh, the god of thunder is back.
Yeah. And there's even like in the Rig Veda, there's even talking about essentially the Maruts and like what's going on with the Maruts kind of after all of this happened, and talking about the Maruts causing all of this chaos and stuff. And I think that's like the resulting debris field from all of this. What was the other thing I was just going to say? Shoot, I forgot. Hopefully it comes back to me.
Yeah, so the end of all the myths is kind of interesting, because what they say is when the ice age comes to a sudden end 11,703 BC years ago, the ice dams which had blocked the flows of the rivers were suddenly and catastrophically breached, and the waters of the massive glacial lakes burst out in huge torrents.
Yeah.
That may or may not be true.
Right.
Because I mean, the ice dam flooding that we know of that formed the channeled scablands began around 16,000 years ago.
Okay.
Yeah. So this is like a generalization. What they're saying is here, when it finally warmed up, everything melted in the same day.
Right. But it could be that the Scablands formation 16,000 years ago could be attributable to a similar event, right? Like if I was just looking at the infamous Firestone paper, right? There's stuff going on around 60,000 years ago. So it may be a similar phenomena.
Yeah. And we went through all the radiocarbon spikes in the past and found out that the first large spike was 40,000 years ago.
Yeah. I also want to throw out there too that I mentioned the episode earlier, our Decoding Gobekli Tepe episode it was January 14th, 2023. And I'm mentioning this because I'm encouraging our listeners to go back and listen to that again. And one of the things we talked about in there is that, there are these accounts, I don't remember which, it's from the Ojibwa tribe. And they seem to be talking about the period prior to the Younger Dryas, and that everything was like screwed up on Earth. Like the weather was weird and the animals were acting weird and everything seemed off. And then like the Younger Dryas happens and then like basically things ultimately go back to normal. So again, it's a story that talks about this catastrophic thing actually kind of righting things on Earth ultimately, which is very interesting. So, I mean, this makes sense, right? Because with you've got the bowling alley rod and then this weird temperature drops and then it comes up again, it drops again, it comes up again. So yeah, of course, animals are going to be very confused. There's going to be a lot of extinction. There's going to be freezing and thawing, and you don't know what the heck is going on. Like things are not right on Earth. And then this comet comes along and there's some kind of impact and something happens and then things become stable again. So it's so interesting, right? Because I was thinking about this in the context of Gobekli Tepe, and we have many times hypothesized that the snakes that appear on the pillars of Gobekli Tepe are representative of comets or meteors or both. Because you could certainly see how a snake would represent a comet in the sky, but we're also looking at the snakes as like being like evil serpents or something, but they're not, right? In the end, it's the comet that's the hero here. So
the comet is the hero.
Yeah.
There are a number of obvious parallels between the story and the Rig Vedic legend of Indra killing Vritra. I can't say that word easily.
I know, it's very hard to say.
While Indra's killing of Vritra has released the waters of the 7 rivers, Marduk's slaying of Tiamat released the waters of the Tigris and the Euphrates. So Tiamat is the snake, right?
The sea serpent, yeah.
Right.
Yeah.
So that means that if Marduk is the comet, then Tiamat is the plasma discharge.
I think Marduk is the plasma discharge. Right, because it's talked about as if Indra and Marduk and even Zeus, that they're using their thunderbolts to kill the serpent, the evil thing.
So what's the serpent?
The serpent is the evil thing. It's whatever is holding back the water and screwing up life on Earth.
What is that? That's weird. The Ice
Age
is the weird. Serpent.
I mean, that's the thing that's sort of like not, and maybe this is a function of like, okay, imagine you're living in this time period where the climate's really bizarre and there's not, the water is being held back. You want your rivers to flow or anything. You're not going to know what's causing that. But why does it end up being the same? Well, maybe this is just a function of culture being passed down, stories being passed down. Why it's always a sea serpent? Like, you have to come up with something, I guess, to explain why life on Earth is screwed up. And somebody came up with a sea serpent for some reason. I mean, there's got to be a reason for that. We just haven't discovered what it is. And the other thing that I think is interesting is, and I've been wondering about this a lot, right? Like, again, in that episode from a year ago, we talk extensively about Pillar 43, which seems to indicate a very specific date that would align with the Younger Dryas period. But the thing that is missing from anything that we've seen so far at Gobekli Tepe is an illustration like of the cause of things, like what is representing the comet on those pillars. Like that's the part that we haven't identified yet, and it's really interesting. Like, why is that so hard to find? It's got to be there somewhere. The hero of the story and the what would you call it? The devil of the story.
Interesting.
The protagonist and the what, I forget, what do you call the the evil person that gets slayed in the story? Whatever, it doesn't matter.
The bad guy.
The bad guy, yeah. I mean, that's why I'm calling it the devil or whatever.
Now, a horse comet is interesting as well. Do you know about that concept?
Yeah.
Yeah. So if a comet is got a very interesting path of travel, when viewed from Earth, appears to look like potentially the mane of a horse
Or
mane.
the tail.
Or the tail, yeah.
Yeah.
And so that's how the whole idea of horse comet. What do they say in here about that?
Well, they talk about it in reference to like a horse's tail.
Oh, there we go. There's a picture.
Right. Well, and then the other thing that's interesting too, right? Again, you've got Indra and Marduk, and I think Zeus has a chariot as well. Like they're all in chariots that's, driven by a horse. So there's that.
Interesting.
Yeah.
Now, so the question is, what's going on? Is this a one-off event? This younger Dryas event is just the comet Encke event, or is this 1 million years of Earth? Are these cycles each time we go up in one of these verticals? Is this when large objects hit Earth?
Right.
For some reason on this regular periodicity. I mean, it's ridiculous.
Right. So again, I go back to what I said early in the show. I mean, obviously there's a pattern here, and it's so abrupt when it shifts that this can't be explained solely by Milankovitch cycles. Something extreme is happening on a regular basis.
Yeah.
The periodicity may change a little bit over time, but something's happening.
So back before 430 is a different pattern, but starting at 430, it's abrupt rise, 15 to 20 C, stay warm for 10 to 15,000, and then drop straight down into the Ice Age. Ice Age ends, straight down into the next glacial maximum. Ice Age ends, straight down. Ice Age, straight down. Ice Age, straight down. And now we're at the next Ice Age ends, straight down.
I mean, frankly, like one of the best, can you go back to that graph? One of the best explanation, this one. I mean, one of the best explanations for this could be a comet, because let's say at 430 we have a big comet that for whatever reason enters our solar system, gets captured, and then ends up in some kind of regular periodicity, and now we're on a schedule. So perhaps that's what's happening here, that we're on a schedule of running into the debris stream of said comet, and that I don't know what it's, to me, that's a better explanation than saying that, like, I don't know, that the sun nova's on some regular schedule, which we've already debunked. It's a better explanation for the periodicity, I think.
So there's a couple things we can look at. We can look at one of those 100,000 year cycles in great detail, but first let's look at all of them. And what you're going to notice is that massive amounts of dust accumulate at certain points, which is directly related to the end of the Ice Age. So this is the dust in purple. See the purple?
Yeah.
Throughout, as we drop down into the Ice Age, the dust accumulates all the way to the end of the glacial maximum, and then the temperature rises and the dust goes away almost at an instant. No dust goes away. And this has to do with the fact that the ice caps capture all the fresh water, all the land becomes extremely arid, and the entire planet is laden with dust. And you can see that as soon as it warms, everything starts flowing, all the dust is back in the water. No more dust. Another interesting thing you can glean here is CO2 takes hundreds of years to rise after the temperature goes up.
Yeah.
Because CO2 is a response from our oceans to a warming Earth.
Right. I was about to say the key word is after the temperature rises.
You can see the dust right here during the Bowling Alarod stopped as soon as that first 27-meter rise there, and then we get the Younger Dryas event here.
That's fascinating.
So dusts are interesting, but more importantly, I wanted to talk about insolation. The insolation is always at the maximum when we rise up.
Okay.
It's always during, so here's a peak in insolation that corresponds to a 100,000-year cycle. Here's the other peak. That's this cycle. Here's the peak. That's this cycle.
So what that corresponds to, like eccentricity?
This is corresponding to the amount of solar insolation at 65 degrees north. So that would be, that's controlled by all of the Milankovitch perturbations.
Yeah, okay.
So this would be when all of them get close, when the northern hemisphere is all closest to pointing towards the sun, and it all comes together here at one of these peaks.
Yeah.
And the Milankovitch idea is that now that the Arctic is the closest to the sun and always pointing to the sun at this point, the Arctic melts. That's not true, though. Because even at these times of high insolation, the Arctic goes dark for the winter and stays below freezing. People don't get that.
Right.
It's minus 60 there.
Right. Like you need an enormous amount of insulation to like change that, but nothing's going to change that if there basically is none because it's dark, right?
It's
like
so
there is
weird
none.
that people think the Arctic is catastrophically warming and it's minus 62 on Greenland today.
Right. Like what do you think? It's like 50 degrees up there? Because that's not the case. Stuff doesn't melt at minus 10, by the way. Like that's the weird part, right? It's like if it's any warmer than minus 50 or whatever, then it must be melting, but that doesn't make sense because it's not melting at minus 10.
Blue line?
I'm sorry, what? You were cut off a little bit there.
Do you see the blue line here?
Yes.
So that's insolation. And what you should glean from it is it's so slow to change that it's definitely not creating this warming.
Right, exactly.
Why didn't it warm up that much right here when it's a similar curve? You know, it only came up a little.
Yeah.
Halfway.
Yeah.
So there's definitely something we're missing. You should also see that here that there is no regular 26,000-year cycle of temperature. So that whole cycle, the 26,000-year cycle, is iffy at best. I've gone back into the long scale cycles here, and you may be able to pick out a precessional signal in here where you're going to get, especially like in this one, we have 1, 2, 3, 4, 5 spikes in 110,000 years. Those may very well be the great year. And it's just in the last 300,000 that the great year is really defining itself. See how there's spike, 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 spike. Yeah, those are the 26,000-year cycles.
I actually went through one of these graphs once and started counting the spikes, and it's not really consistent for every 100,000 plus year cycle.
Sometimes there's 4, sometimes there's 5.
Sometimes there's 6. Yeah.
So
but that may very well
there
be
is a rough correlation.
Yeah, and it may the irregularity, the part of it that's not super regular, may just be a function of how all of these variables interact with each other. But obviously, the big signal is the 100,000 year, but it's more closer to like what 112 or 110.
Yeah, 110, 105. It varies.
Yeah.
And so, if the Milankovitch hypothesis of orbital perturbations is not, in fact, our orbit changing shape, our orbit changing ellipticity, and our planet wobbling, if it's none of those, if our planet isn't wobbling because we're stuck in an electrical shell, which would prevent it from wobbling, it would almost be statically stuck there in with a perfect north-south rotational orbit that's stuck, that can't wobble.
Mm-hmm.
In a gravitational model, you can use the wobble because you can spin a top and watch it wobble.
Yeah.
But I don't think we're in there. I think we're in a Birkeland current, and it's the circular motion through the current that might be the 26,000-year cycle, up and down.
Mm-hmm.
And then maybe that gets wider and thinner every 100,000 years, which is the eccentricity.
Right.
And when we get wider and thinner in a 100,000-year periodicity, we go through very bad streams of things. Or we have this electrical environment which attracts the already existing Taurid stream towards us, because we do go through it all the time. But what if something made us extremely vulnerable and magnetic and draw these things in? This could be an electromagnetic effect, the 100,000-year cycle.
Oh, yeah. No, and I don't really doubt that in a certain way. Maybe not quite in the way you're saying, but
we'll talk more soon.
Listen to Revolution Radio at freedomslips.com, and we'll be right back after this message.